Hello everyone, here is FRQ number 4 from the 2024 AP Calculus AB and AP Calculus BC exams. Make sure also to check out the description below where you can see the link to College Board to see this FRQ along with all of the others. So let's get to it. Question number 4 gives a graph of a differentiable function f between the x values of -6 and 7, and it tells us where there's a horizontal tangent line. And R is the region in the second quadrant bounded by the graph of f, and the vertical line x equals -6. And it tells us that region R has an area of 12. So part A gives us a function g of x defined as the integral from 0 to x of f of t dt, and we are asked to find the value of 3 g of x values. So for the first one, let's find g of -6. So to do that, we would plug in an x value of -6. So that'd be the integral from 0 to -6 of f of t dt. Now, I like to put the lower x value on the bottom, so I'm going to switch these limits, and I can do that as long as I make the integral negative. And the integral from -6 to 0 of f of t dt, well, that is the region R, and it was given to us in the problem that region R has an area of 12. Therefore, this function value of g of -6 will come out to be -12. Now on to g of 4. And g of 4 would be the integral from 0 to 4 of f of t dt. That would mean we are looking for the area under the f graph from 0 to 4, which is going to be this triangular region right here. And we can find that area by finding the area of a triangle, which is 1/2 times base times height, or 1/2 times 4 times 2. And you can see that that would be a +4 in this example. So g of 4 is 4. And then lastly, we need to find g of 6, and that's going to be the integral from 0 to 6 of f of t dt. Well, we already found the integral from 0 to 4 was +4, so we just need to look at the area of this triangular region down here from 4 to 6. And so that would be 1/2 times base times height, or 1/2 2 times 1, which is 1. So now if I combine these, well, I would have the integral from 0 to 4, which was 4, and then the integral from 4 to 6, which is going to be a -1, and so the answer is going to be a +3, and that is part A. All right, let's go ahead and move on to part B. And in part B, it says for the function g defined in part A, find all values of x in the interval from 0 to 6 at which the graph of g has a critical point and give a reason for your answer. So a critical point is going to be where g prime of x equals 0. Now, if we look at how g of x is defined in part A, we can see that, I'll go ahead and write it out again, that g of x is the integral from 0 to x of f of t dt. So we need to think about what is the derivative of g of x, or g prime of x. And in that case, I would use one of the parts of the fundamental theorem of calculus to write that g prime of x is equal to f of x. So what I'm looking for is I'm looking for where g prime of x, which is the same as f of x, is equal to 0. That's where I will get the critical points. And because we are given the graph of f and we're looking between 0 and 6, we can see that right here at the x value of 4, I can see that g prime, which is f of x, is equal to 0. And that would be my answer. And my reason is that g prime of x, which is equal to f of x, is equal to 0. And then lastly is part C. The function h is defined by h of x. Now we have this new integral from -6 to x of f prime of t dt. We want to find these 3 values, and we'll show the work that leads to our answer. So the first is to find h of 6. And plugging in 6 for x, that would mean the integral from -6 to 6 of f prime of t dt. Now the difficulty with this one is we aren't given the graph of f prime, so we can't find the area under the f prime curve from -6 to 6. So in this case, I would have to use the fundamental theorem of calculus, which says that the integral from -6 to 6 of f prime of t dt would be equal to f of 6 minus f of -6. Now those are function values that we can get from the graph of f of x. F of 6 we can see given in the problem is -1, and then f of -6 given to us also is 0.5, And so we get an answer of negative 1.5 for h of 6. Now for h prime of 6, well, that involves finding the derivative of the given function. So I would have to write that h prime of x is equal to f prime of x using one of the parts of the fundamental theorem of calculus. So I can see that h prime of 6 is equal to f prime of 6, which means I am looking at the slope of the line that goes through 6, or the slope of this line segment here. And if you think about slope as rise over run, or thinking about going from this point at 0, 2 to this point at 6, negative 1, let me go ahead and write out those points. So if you found the slope and did y2 minus y1 over x2 minus x1, you would see that we would have a slope of negative 1/2. So that's going to be the value of h prime of 6. Lastly, we have to find h double prime of 6. And so I'm going to write out that h double prime of x would be equal to f double prime of x. So h double prime of 6 is going to be f double prime of 6, which is the second derivative. And so we are given the graph of f, and if we look at the slope of the graph of f, that gives us f prime. And then if we think about the rate of change of that slope, that would give us f double prime. And you'll notice that that slope stays a constant negative 1/2 during that whole time. Therefore, the rate of change of that slope is 0 because that slope does not change at all. So that's it. That's question number 4 from the 2024 AP Calculus AB and AP Calculus BC exams. I hope you found that helpful. We'll see you in the next video. Bye, everyone.